Good afternoon and welcome to BBI International's latest webinar in our ongoing series. This is Sue Redkish. I'm a senior editor with BBI International, and today we're going to be talking about rail moving forward, risk management, and 111 tank cars. This certainly is a timely topic. Nearly 1/5 of America's domestically produced transportation fuel is now originating in the Midwest. Bakken shale oil output exceeds 1 million barrels per day, and domestic ethanol production is just under that number at about 930,000 barrels per day. Both of those rely upon rail to move the commodity from the production site to the market. All that increased rail traffic, plus some pretty high-profile train derailments of Bakken crude in the past year or so, and that's on top of earlier ethanol derailments. They've really heightened public scrutiny on rail safety issues. And as you may know, the comment period closed just a few days ago on the U.S. DOT's proposed new rules for hazardous materials with enhanced tank car standards and operation controls for high hazard flammable trains. We have two speakers in today's webinar, Tom Simpson from the Railroad Supply Institute and Matt Henry with Pinnacle Engineering. They're going to be addressing a couple of the aspects of the many issues that have been raised as a result of these headline-grabbing incidents. And just so you know, we are recording this webinar. You'll be getting an email in the next day or so with a link so that you can listen in again if you like. But first, we'd like to acknowledge our sponsors for today's webinar, Northern Plains Rail Services.
Northern Plains Rail Services, also known as NPRS, is a sister company to Northern Plains Railroad. They provide an extensive variety of rail services, ranging from full-service locomotive and rail car repair in our shops, as well as mobile and emergency services for locomotives, rail cars, track repairs, and full-service industrial switching services. NPRS has facilities and mobile repair trucks located in Minnesota, North Dakota, northern Alberta, and parts of western Canada. These facilities are full service with mobile repair trucks serving remote areas for all services. Our commitment to customer satisfaction and our attention to detail is apparent in all of our services offered. And most importantly, all services are performed to certified railroad standards. This gives you added value and dependability with peace of mind. Our transportation services include track design and engineering and new track construction, including emergency repairs, complete sales, leasing, and maintenance of locomotives, turnkey industrial switching services, and total rail car repair services, including tank car service, equipment, and repair. It is the policy of NPRS to provide safe and efficient transportation service with personal safety as an absolute requirement in all activities. All NPRS employees are professionally trained and certified and tailored to meet your needs at any specific site. Please check us out and see how we can be your turnkey railway industry partner. Visit our website at www.nprail.com.
A big thank you to Northern Plains Rail Services. Their sponsorship is the reason we can offer this as a free webinar this afternoon. One more thing before we start. There will be time for questions after the presenters are finished, and you can direct your questions by using the webinar control panel. You should see it in the upper right-hand corner of the webinar screen. There's a little red arrow that if you click on it, it will open up and you'll see a line that says question. If you don't see a box where you can type in your question, go ahead and click on the plus sign and that'll pop the box open and you can type a question. I'll be managing those questions. I'll pick a few for the question answer period at the end, and I also have the option of sending those questions directly to a speaker, although I will not do that during their presentations. So our first speaker this afternoon is Tom Simpson, President of the Railway Supply Institute, which is the international trade association of the rail and rail rapid transit supply industry. Tom is based in Washington, D.C., where RSI supports the rail supply industry with its government relations program. Tom, What can you tell us about these tank car changes coming down the rail?
Thank you, Sue, and good afternoon, everyone. As she said, I'm Tom Simpson, president of the Railway Supply Institute. We're a trade association that represents the railway supply industry in Washington, D.C. Think locomotives and freight cars and communication signaling technology and maintenance of way equipment and passenger equipment, and that is the domestic railway supply industry. I'm talking to you this afternoon on behalf of the RSI Committee on Tank Cars, 7 companies that own and that build virtually all the tank cars that operate in North America and own and provide for lease over 70% of them. So the ethanol boom, tank car build boom of the mid-2000s and the more recent oil tank car boom is and the resulting controversy is of much interest to us. You probably all know the timeline. This is a reverse timeline for some reason. So let me work from the bottom back to the top. Back in the 2008-2009 time frame, there were several high-profile ethanol accidents that led the Federal Railroad Administration to come to the Association of American Railroads Committee on Tank Cars and ask for that committee, of which we have membership on, asked that committee to consider designing a tank car that would remove risk of moving ethanol by rail. The industry responded to that and created a CPC 1232 car. It's also known as the P1577 car. The P1577 car, a petition was sent to PHMSA in early 2011 asking PHMSA to adopt the new standard as federal requirements. PHMSA never acted on that. However, by later that summer, the industry agreed to voluntarily build tank cars to the new, tougher standard. For tank cars ordered after October 1st, 2011. For crude and ethanol, we are building cars to that standard today. Intervening the next summer was Mechanic and the horrible tragedy at Mechanic, which forced Transport Canada to act on tank cars and then ultimately forced our U.S. Department of Transportation to move on tank cars. Our PHMSA issued an advance notice of proposed rulemaking a year ago, December, and we filed, the Railway Supply Institute filed comments to that ANPRM. The notice of proposed rulemaking came out in July. We just filed comments to that on the 30th of September. Conventional wisdom in Washington, D.C. anticipates that a final rule will be completed by sometime in the first quarter of 2015. If you're interested in our comments or the comments of anyone else, they are on the PHMSA website, and you can go there. You will find thousands of commenters ranging from the Railway Supply Institute and the Association of American Railroads and shipper groups to interested cities and villages and others interested in the movement, especially of crude by rail. The proposal that we submitted to PHMSA on this week is comprehensive. It's 60 pages long. Obviously, 4 bullet points. That doesn't cover 60 pages of comments, but basically, we argue for a holistic approach to improving the movement of hazardous materials by rail. That includes taking steps to ensure that the trains are operated safely, the roadbed is maintained, the material is classified correctly and thus put into the correct tank car. And then we have very comprehensive proposals for new tank cars and modification of the current fleet so that the risk is removed, additional risk is removed from the tank car. Harmonization is essential. Canada and the United States are working on parallel courses, and we have argued both in Canada and the United States that harmonization is essential as tank cars operate throughout North America, not just in the United States and Canada and Mexico. PHMSA proposed something called a high hazard flammable train, which would require cars and trains with tank cars and trains with a certain number of tank cars in them carrying flammable material to be built to a new standard or modified. We don't think that works. We have been arguing all along for a commodity-based rule, and we continue to argue for a commodity-based rule. Option one is sort of inside the Beltway lingo. PHMSA had offered 3 options for new tank cars. Option one was a 9/16 inch shell with ECP brakes and some other features. We have argued against that, but we have a very substantial proposal. We recommend that newly built tank cars transporting crude and ethanol should be built with a 9/16 inch tank shell. They should have a jacket, full height, half-inch head shields, top fittings protection, a reconfigured bottom outlet handle, a reclosing pressure relief valve made out of normalized steel, and have a thermal protection system. This is consistent with option 2 in the NTRM. Newly built tank cars transporting the balance of other Class 3 flammable liquids in packing group 1, 2, or 3, we recommend should be built with a 7/16 inch tank shell with all the same features that we've argued for the 9/16 car. We have a very extensive modification program, and I'm going to get into that in a second, but we argue that the current fleet, we should be allowed to modify the current fleet. And we also have very aggressive, but not as aggressive as DOT, very aggressive timeline for the modification. You've probably seen this chart. This is compiled by my friends at the Association of American Railroads. This is the DOT 111 fleet. I should tell you that DOT 111 tank cars are not pintos on rails, nor are they rolling time bombs. They operate safely every day of the year throughout North America, built to industry and federal standards that were in place at time of construction and still in place. Having said that, we recognized in the aftermath of Mechanic that status quo wasn't acceptable, and so thus our rather detailed proposal to PHMSA. You're going to find, too, when you take a look at this chart that the numbers don't add up. It's because this measures a tank car with a load in the last year. So tank cars frequently move from petroleum service to ethanol service to other flammable liquid service. But we think this is a pretty fair snapshot of the fleet as of May 1st, 2014. As you can see, 48,500 tank cars in crude service, another 27,845 in ethanol service, and the remainder in the other flammable liquids. Non-jacketed DOT 111s are the legacy cars, as we call them. Those are the older cars that were built to the standard currently in place. The CPC 1232 cars are the cars that we have voluntarily built to the standard that we petitioned DOT to accept. We have surveyed our membership, and we estimate that by the end of next year there will be over 57,000 CPC 1232 cars in service. We have also, these are the cars that we think we ought to be allowed to modify these cars to remove the risk from these cars, but continue to allow them to operate. We have very detailed, as I said, very detailed proposals on these cars, and I will get to that in a second. Just a couple of points. One, we don't think all the non-jacketed DOT 111 legacy cars will be modified. We estimate that roughly 30% of those will fall out, but we think that the full CPC 1232 and the both jacketed and non-jacketed will be modified. We have done a survey of our shops and other private shops, and we have come to the conclusion that it will take 6 months to a year for the shops to ramp up to do a modification to do modifications of this tank car fleet. They're going to need to hire people. They're going to need to acquire materials. They're going to need to set up programs with the car owners to bring those cars in. Once the tank car shops are up and running, we think that they can add roughly 6,400 cars a year in the second year to their current capacity, and that leads us to a timeline for modification of these cars that I'm going to get to in a second. This is tank cars every 10 years have to be requalified. Every 10 years, the cars are brought in, and the tanks are inspected for corrosion and cracks and things like that. You will see that because of the ethanol boom in the mid-2000s, that from 2015 to 2020, there are a large number of tank cars that are due to be requalified, over 200,000 if my math works. And that adds problems to adding to the capacity of the shops that are capable of doing the modification work. Nevertheless, having said that, we think that at least 6,400 cars can be modified per year. Some of our members think that number can go higher, as the modification proposal that we put in, if it's accepted, matures. We think we can get it even more cars, but this chart shows you the difficulty that we are going to have modifying the current fleet. PHMSA assumed that the new tank car builders could make up the difference. We also happen to represent the new freight car building industry. Tank cars historically were a 8,000 to 12,000 unit a year business. In the first half of this year, new tank cars put in service were roughly 17,500. We think the capacity of the tank car builders is roughly 35,000 per year. Some of our members think that could be higher, but I haven't seen any numbers higher than 40. So if you do the math, that's over the next 3 years, 105,000 tank cars, the capacity of the car building industry. There's a current backlog of cars but not ordered of 52,600. That leaves an available capacity between now and 2016 of roughly 52,400 cars. We estimate that 60% of that is available for new crude and ethanol cars, as there are other types of tank cars that are ordered and built. You can see that the legacy crude oil ethanol fleet is roughly almost 59,000 cars. The capacity to replace these cars immediately is not there. And also remember that a tank car is a 50-year asset. The median build date for those 111s in that chart I just showed you is late 90s, early 2000s, and so those cars have a nice long life ahead of them, and you know, that should play into PHMSA's decision-making process on moving forward on new cars and modifications. Here is our modification proposal and timeline. We have argued that the legacy DOT 111 crude and ethanol cars should be allowed to be modified with full height head shield, jacket, thermal protection systems, the pressure relief valve, the fixed to the bottom outlet valve handle, and increasing the GRL to 286,000 pounds. If I do my math correctly, that's over 50,000 cars there. The jacketed legacy DOT 111s, 10,536 cars there. Both those sets of cars we think can be modified by the end of 2020. That assumes that a rule is in place by the first of this year. Obviously, a rule will not be in place by the first of this year, we don't think. So that would be 72 months after the rule is in place. Those cars would be modified, or they wouldn't be allowed to operate. the CPC cars, non-jacketed CPC cars, we propose to jacket those. We propose that that be done by December 31st, 2022, or 72 months. The remainder of the fleet, a variety of different modifications for the remainder of the fleet, and we recommend and think that those can be done by 2025. An aggressive schedule, not aggressive for some, but we think that this is doable and should be adopted by PHMSA. Here's our schedule of costs and out of time service. I'm going to point you to, I know you're going to get these, be able to access these charts. If you have any questions, you're more than welcome to either call me or email me, but I'm going to point at two numbers, two categories on this slide. The full modification of a non-jacketed legacy DOT car, we estimate is in the $48,000 to $70,000 range, and it depends on whether you have to do any work on the trucks or not. We have opposed the installation of ECP brakes on tank cars. It's a part of the our DOT proposal. In Transport Canada has drawn a line in the sand, and they are arguing that any cars new cars going forward should be ECP brake equipped. We estimate that that the cost of installing ECP brakes is in the $7,000 to $8,000 range. ECP brakes can only work when the entire train is ECP brake equipped, including the locomotive, and we think that that is not necessarily a feasible step to improve the safety of the movement of crude and ethanol trains. We argue for distributed power and end-of-train devices. That is my presentation this afternoon, and as said, I'll hang around and answer any questions you might have once Matt has finished his presentation.
Thank you, Tom. Remember, you can direct any questions to Tom from your webinar control panel on your screen. Our next speaker is Matt Henry. He's with Pinnacle Engineering. He's going to be taking a different take on this whole issue of safety around these flammable hazardous liquids. Pinnacle provides a full range of environmental, civil engineering, and remedial field services, serving the expanding environmental needs of railroad, industrial, manufacturing, and renewable energy clients. Matt is a project engineer with Pinnacle. He's based out of Omaha. He's going to be talking to us about risk management and contingency planning. So Matt, take it away.
Good afternoon. Here to talk about risk management and contingency planning with Pinnacle Engineering. Pinnacle was started by Jim Holland in 1991, servicing environmental, industrial needs of railroads, foundries, heavy industry, and the renewable fuels. So commercial for Pinnacle, I guess. Pinnacle has been involved in several emergency response activities, including Bakken derailment and benzene, ethanol, diesel, even the Metrodome in Minneapolis. So kind of a range of emergency response type activities. Risk management and contingency planning are kind of two sides of the same coin, and hopefully you never see the third side with emergency response, but should Murphy come camp out, at least you're prepared to carry out what is planned and not be scrambling. Risk management, there's several different drivers, or whether it be regulatory, you do it because you have to, you do it because you want to and be a good partner in your community, and other financial impacts that could happen to shareholders and owners of the company should things go wrong and you're not prepared to handle it, or things go wrong and suddenly you can't operate and business is disrupted. A lot of things, transportation or linear, regional, or distributed kind of assets or more fixed facility. I'm more assuming that there's more fixed facility folks here and less of the transportation, so I kind of geared toward that. But be aware of where you're at and what's next to you. A lot of impacts as far as stuff that leaves your site impact others around you. Whether it be a wetland, a river, a stream, your neighbor's prime farmland that you're super proud of, or daycare center, hospitals, churches, what have you. Contingency planning is the other side of it. So you have the risk, you know what's going on, and you know what you have, where you're at, who you can impact. Contingency planning is more or less okay, what if? What if this does happen? What are we going to do to respond to this? Who's going to help us? Who's going to be in charge? Who are we going to call? They're calling 911, a fire department going to show up? Are we going to call specialized contractors? Where are they? Who are they? And how far can they have to come to get to you? And when they do get to you, what are they going to bring? Who are they going to bring? Or are they going to do for you when they finally do show up? Railroads kind of or trucking firms are the more distributed logistics. Kind of an interesting situation with them is that they're all over the place and they can visit kind of anywhere. So there's different planning aspects with distributed assets. But it's kind of the same process and thought process going along. When the fire department shows up and you have an incident, is not the time to figure out who's going to be in charge. You need to figure that out beforehand and have a plan in place. It's the same fire drills for occupied buildings and schools and whatnot. You have your evacuation plan. You know what you're going to do before it happens, so you're not scrambling. So internal things is, something happens on the line, something happens in the facility, who do they report to, what do they do right away, and what goes forward as things progress, as it's a little incident to a big incident. And then, heaven forbid, if it's a big incident, suddenly you have outside people coming on, you have the press showing up, you have public relations, all kinds of other headaches. Who's in charge of that? Is it kind of thing to think about? How prepared are you? It's kind of always the question, or can you ever be too prepared? Or the other side of it is, if you plan too detailed and too controlled from the top, does it even work? The best way to even think about that is through training. A simple tabletop exercise with some key people and some people that are actually around the hazards of the process can yield a wealth of information. You can have the guy out there around the process every day, all day, and suddenly has this gem of insight that no one's thought of yet, and then works to incorporate that in. So the third part of it is the emergency response. And hopefully this is when something happens isn't the first time you thought about it if it could happen, but your site has unique features. It is different than any other site because of where you are at and what you are, who you are. So it is understanding of those features and where things migrate and potentially go to that would have the greatest impact on what you should do and when you should do it. And then trying to call a contractor and drill up your facility after something's already happened without a contract in place could be problematic. So kind of have retainers lined up, have contracts all situated so you're good to go when you're ready to go. All right, the worst conceivable thing that has happened, and suddenly we got to respond to something. Something gets out, now what? The key thing, we have both ethanol, we have crude, is know the hazards of your product. Ethanol is different than crude, crude is different than ethanol, that's different than benzene. So the key physical features of your product is going to kind of dictate what you're going to do, whether that's going to be boom or things like containment or what have you. Your big advantage of a fixed facility is you know what's there over a transportation company, which it could be anything. So you don't have to spend the time to figure out what it is. You can have that kind of planned and thought out beforehand. Two types of releases, kind of common is the transportation. That's kind of your large derailment that is kind of more the purview of the railroads and those folks that are in charge of shipping. More fixed facility is your operational releases, and they can range from a small scale on up to a larger scale. Then the actions that your facility personnel take in the first minutes of a release is going to have a huge impact on the overall scope of that release. The preparedness and planning, so if your line guys know what to do, when it happens, you're going to save valuable minutes and getting this first action, this critical action take place. A small spill that's contained on site, remediation, removal, and all aspects of after that release, you're talking $10,000 to $100,000. However, if it gets off your site into surface water, it's a blank check. You're talking long-term remediation, long-term environmental impacts. Quick case study. This one happens to be ethanol, but it could easily be crude. It could easily be anything else at a fixed facility. This was actually an overfill of a tank car. Won't get into the specifics of how it occurred, but it did occur, and it released about 28,000 gallons of ethanol onto the ground. The secondary container was quickly overwhelmed, and it kind of went off. The first hours of the incident, they were able to get a vacuum truck out there and able to get a lot of the liquid that was on the ground contained into secondary containment, and then quickly did some soil excavation to minimize impacts to groundwater. Quick action by the facility, both containment and then with the removal of the product, leads to quick closure and minimizes environmental impacts. Kind of the summary of it all. You know what you are, know what your risks are, and then just plan out the what ifs. The drills and plans is critical into assessing whether your plan is even workable or if you're over-prepared, under-prepared, what have you. Until you practice it, you're not going to know until how that's going to work. Assets, TransCare is a great asset for emergency response. It's sponsored through the railroads, but it's free emergency response training for those that fit it where they want it. And that's Pinnacle, our office, and contact information. Back to you, Sue.
Okay, thank you, Matt. So we have a couple of questions I'll get to. I do want to point out that the webinar presentation, you'll be getting a link to the recording of it, and you can get screenshots of particular slides if you want from when you get that link to the recording. And if someone wants to get to it who doesn't have the link, it's available on the websites of the magazines associated with these lines. So if you go to ethanolproducer.com or you go to biodieselmagazine.com or the Bakken.com, any of those, you can find the tab across the top that says events. There's a drop-down menu, and you can access the webinars there and watch them on demand. So I have one question for Tom, and if Tom and Matt would both, if you've muted your phones, if you'd be back on. I know the ethanol industry and others in the oil industry have argued that requiring these costly retrofits to 111 tank cars isn't the way to go. I mean, they're saying it would make more sense to focus on avoiding derailments. What are the chances that the DOT might make some modification on these car upgrades in response to that sort of comment?
I think that the signals from both Canada and the United States is that tank cars are, and modification of tank cars, and a new tank car design is going to be a part of this rule. And as I said, we decided last summer that a summer ago that the status quo wasn't acceptable, and thus we took a look at the 111 design and looked at how we could continue to remove risk from those tank cars and moving crude and ethanol. Tank car designs have evolved over time. The original tank cars were barrels on flat cars. A tank car during World War II, if you ever see a picture of them, is nothing but rivets. We have spent millions of dollars to the Association of American Railroads and the Railway Supply Institute on tank car research. We have a very detailed accident database. Tank car designs are evolving and continue to evolve. I believe this is the next step in the involving of tank car designs as we look to continue to remove the risk from moving crude and ethanol and other flammables. I don't think that DOT, if that's the question, is going to back off from addressing tank car designs.
Okay. Another question for you, Tom. The DOT and Transport Canada standards typically match, but this time around they're very different. What's being done to harmonize these two different standards?
Well, we have met with both our U.S. Department of Transportation and Transport Canada and argued for harmonization, as have shipper groups, and we continue to meet and argue, and we argued in our submission to DOT. I do know that Transport Canada and the Department of Transportation meet regularly. As a matter of fact, there's a Transport Canada official in Washington this week. Harmonization, they understand that harmonization is important. The Transport Minister in Canada understands that harmonization is important, and I've got great faith in our two governments that ultimately the regulations will be harmonized, and tank car builders will build to one standard, and cars will be modified to one standard, and they can operate thus both in the United States and Canada.
That's good, and hopefully it'll happen sooner than later. I've got a question for Matt here. Matt, do rail cars have to carry emergency response products for oil spills?
I don't think so. The emergency response railroads are typically staged at fixed locations around the network.
Okay.
The answer to that, if you can hear me, the answer to that is no. Railroads spend, I'll defend my friends in the railroad industry, they spend lots of time and lots of money educating online emergency response folks. I'm on the board of the Transportation Test Center in Pueblo, Colorado. Through donations from my members, there are tank car training facilities out there, both generic tank cars and crude oil tank cars, and both railroad emergency response folks and local emergency response folks have begun to take courses out there. But the fact of the matter is that there's nothing on a tank car that would, other than the steps that we have taken to control fires and those kinds of things, and valves and those kinds of things. There's nothing else on a tank car there's no emergency response kinds of materials on tank cars.
Okay.
Yeah, the tank cars are designed. Sorry, Sue, real quick. The whole point of the tank car is to contain the product inside the tank car. There's no need for any emergency response equipment until it's breached.
Okay. A question for Tom. Agricultural groups, oops, just a second here, I got to scroll down the screen. Yeah. Agricultural groups have come out against the proposed rule, in large part because of the concerns of backups hauling the movement of ag commodities. Can you compare or contrast what your industry is doing to improve car safety to what the proposed rule calls for? Do you feel the industry could improve its safety faster on its own without the federal rule?
We took voluntary steps to introduce those CPC 1232 cars to the industry, as I said earlier, and there will be over 57,000 of those cars in service by the end of next year. However, we do like prescriptive standards, and we like the Department of Transportation to tell us how they want cars built and how they want cars modified. And so I believe it's a partnership between the builders and the owners and the Department of Transportation to reach an agreed upon path forward. As far as service issues, I'm not in a position to comment on rail service issues.
Okay, I'm looking down at the questions that have come in. There's a question here. Have we spent enough time determining why derailments occur and the specific reasons what happens and track conditions or crew issues? Could either one of you comment about your observations as you watch this situation unfold?
I used to work at the Federal Railroad Administration a long time ago, and they have inspectors throughout the United States. Railroads have inspectors. Track inspection occurs regularly. Equipment inspection occurs regularly. There are wayside detectors measuring the health of equipment. A lot is done to ensure that trains operate safely. However, we've argued that more can be done and should be done because tank cars aren't causing derailments, and so we need to do what we can to prevent derailments, and I think that's about where I am on that. There is a very strong safety regime that oversees the railroads, both voluntarily and from the federal government, but obviously more steps need to be taken. There's no common thread amongst these accidents, by the way. If you look at them, most of them are track or equipment or human error kinds of accidents. As I said earlier, the tank cars aren't pintos on wheels or rolling time bombs, and so we do argue that steps need to be taken to ensure that the trains are operated safely.
Okay. Tom, someone asked, are all builders running at full capacity now, or is there room for them to come up to capacity to make these retrofits and build new cars?
Well, as I said, based on we do collect in my office freight car orders and deliveries, and when you see those reported, they come from me, and we think that the tank car building industry capacity currently is roughly 35,000 cars a year. There are others who think that can approach 40,000 a year. There are new companies. There are other companies that are coming online building tank cars that don't belong to my committee on tank cars. I do believe that the tank car builders are looking to increase capacity if needed. So that's sort of the state of the new tank car building industry today.
Okay, and can you cover again? There was a question about how many of these additional cars. I think it was like 35,000 additional coming on stream. Might be dedicated to ethanol, and how many for crude?
That I can't tell you, because I don't know what the cars are who's buying the cars and what they're being used for. I can't tell you that. In our submission to PHMSA, we think that going forward in the next few years that ultimately some 20,000 cars, 20,000 slots in the car building in the car builder's capacity would be available for crude and ethanol, but I can't tell you exactly how many are going to go into crude or how many go into ethanol.
Oh, okay. Okay. So those are most of the general questions, unless another one pops up on my screen coming right now. Need to thank our speakers for talking today. Informative presentations that are filling people in on these issues that are rapidly becoming so important to the industry. And I need to thank again our sponsors for the day, Northern Plains Rail Services, and for their sponsorship. It's an important thing. Without them, we wouldn't be able to present webinars such as this. And just to let you know, you will be able to get this webinar again. You'll get a link to it in an email, or you can get it on the websites of any one of the 3 publications, ethanolproducer.com, biodieselmagazine.com, or thebakken.com. There's a listing for events, and under the events tab, you can pick up on the webinars. And we've got a few more upcoming. The Bakken magazine has a webinar editorial outlook coming up. The National Advanced Biofuels Conference is being put on in October 13th, coming up soon. We have a new magazine that we've just launched called For Unmanned Aerial Systems. So you can find out more about that, and Pellet Mill Magazine's outlook is coming up as well. So I really thank you for listening in today, and hope you have a good rest of the day. Bye now.
Thanks, Sue.